Hello everyone, my name is Arnav and today we'll be going over the 2023-2024 High School Virtual Challenge Meet number 1 for the physics section. I'll be going over all 20 questions in this section. So before we get started, I'll show you all 20 questions so you guys can do this test on your own before I go over each question. These are the questions from number 1 through 8, from number 9 through 13, and number 14 through 20. Alright, let's get started with the questions. For numbers 1 to 3 will be from a certain reading on the physics sections. Like on number 1 to 3, each year you'll have a certain reading where you get the answers to number 1 through 3. This year it was 5 Equations That Changed the World by Michael Gillen. And you just get the answer straight from the reading, so there's not really much explanation for these. Answer to number 1 is E, answer to number 2 is B, answer to number 3 is A. Number 4 is always going to be an astronomy question, and that's just a prior knowledge question. The answer to number 4 is going to be D. Number 5, the SI unit of electric current is what? So I'll quickly define all units over here real quickly. The SI unit for voltage is essentially electric pressure. Electric pressure / potential, I guess. So electric potential, the potential for current to drive throughout an entire circuit. Watt is the unit for power. Ampere is the unit for current. Ohm is the unit for resistance. And Tesla is the unit of a magnetic field. So, just based on the answer to the question would be letter C. Alright, number 6. Carl was driving through a country road west of Sabine at 96.56 kilometers per hour. He spotted a deer on the road and applied the brakes of his car. The car began to uniformly decelerate at 5.6 meters per second squared. How far did his car travel from the time he applied to brakes until his car came to rest? I'll pull up another note just to do all my work for this question. This up a little bit, just see the question. Okay, so first step for any of the physics problems to label what we have. We have the initial velocity, which is 96.56 kilometers per hour. We have the final velocity, which we know is 0 meters per second, because we're trying to find how far the car traveled until his car came to rest. To rest means 0 meters per second. So that's so it's until it completely stops. And we're trying to find how far the car traveled. So the displacement's what we're trying to find. And we're also given the acceleration. The acceleration is negative 5.6 meters per second squared. So, and it's negative because it's decelerating. It's slowing down. So one major step we need to do before we get started is convert 96 kilometers per hour into meters per second, because acceleration here is in meters per second, so initial velocity is also going to have to be in meters per second. So to do that, we know in 1 kilometer, hold up. In 1 kilometer, there are 1,000 meters, and in 3,600 seconds, in 1 hour, there are 3,600 seconds. So crossing out the units and doing the math, you're allowed to calculate on these tests, by the way, so bring that out. 96.56 times 1,000 divided by 3,600. You should be getting 26.82 meters per second. That is your initial velocity. So now, and we use this one kinematic equation. Final velocity squared equals initial velocity squared plus 2 times the acceleration times the displacement. Now it's just a matter of plugging in all the values. What is the final velocity? We got that to be 0 because the car stops. The car's at rest. 0 squared. Initial velocity is 26.82. 26.82 squared. Acceleration is negative 5.6. And displacement is going to be what we're trying to find. So now it's simple algebra trying to find what the displacement is. So we know 2 times 5.6 times displacement equals 26.82 squared. Displacement equals 26.82 squared over 2 times 5.6. And plugging that all into a calculator, you should be getting 64.235 meters. So that's the answer to this question. And what's the closest one to this? That would be letter D, 64.2. Number 7. A 2.44 kilogram block lies on a horizontal surface. The coefficient of kinetic friction between the surface and the block is 0.387. A pulling force of 12.2 newtons is applied at an angle of 36.2 degrees above the horizontal. Find the acceleration of the block. Let's get separate sheet. So, what are all the things we have? We know that the mass of the block is equal to 2.44 kilograms. The coefficient of the kinetic coefficient of friction is 0.387. We know the pulling force is 12.2, but I'm actually not going to write that alone yet, and here's why. The pulling force is at an angle of 36.2 degrees. So if I draw a dashed line here, this would be 36.2 degrees. This pulling force has two components. It has both a vertical component and a horizontal component. If you've done pre-calculus, you might know vectors as something like this. So these two components, instead of writing the diagonal line, you can write it as both a horizontal and a vertical line. Now, to answer this problem, let's draw all the forces in this object. We have the weight force, because the object has mass, so it always has weight force. We have a normal force. In this case, normal force is not equal to weight force. That's one big thing we have to know about this question. And we have the force of friction. We're trying to find acceleration. So we know by Newton's, so we're trying to find acceleration. By Newton's second law of motion, we know acceleration is net force divided by the mass. So we know the mass of the object is just 2.44. We want to find the net force in newtons. So how do we find that? Well, let's find the net horizontal force, and then let's find the net vertical force. Let's find the net vertical force first. What are all our vertical forces? Well, we have weight, we have normal force, and we have so let's just say this would be force in the y direction, force in the x direction. We have force in the y direction. These are all the vertical forces. So how do we set up an equation? We know that since the object is staying on the surface the entire time, the forces have to be completely balanced. We know weight force is going down, and then the normal force plus the y direction force is going up. So that's one equation we can set up with that. We know the formula for finding weight is mass times gravity. So the mass is 2.44. Gravity, the acceleration due to gravity on planet Earth is 9.8. That's a constant you should know during the test. Normal force is actually what we're trying to find here. And so we can actually leave that because we don't necessarily know that yet. Since there's an upward force, it is not equal to weight force. That's one huge thing you have to know. Normal force is not equal to weight force in this problem. And the upward force is going to be, well, if we draw a triangle, this is 36.2, this is 12.2, and we're trying to find this. We can just set up sine of 36.2 equals y over 12.2. So then you can get the force of y to be 12.2 times the sine. 12.2 times the sine of 36.2. So you set up this equation. Now you want to solve for normal force. And plugging everything into the calculator, 2.44 times 9.8 minus 12.2 sine of 36.2. Making sure my numbers are right before I plug it in. Degree, make sure your calculator's in degrees, by the way. You would get the normal force be equaling to 16.707 newtons. That's the normal force on the object. So those are the vertical forces. Now let's try to find the net horizontal force. Unlike the vertical forces, the net horizontal forces are not balanced. So there is a net force, a positive net force, or actually there is just a net force in general in this in the the horizontal direction. That would be the force applied to the x direction minus the force of friction. Notice if I'll draw in red. And honestly, I should have done. If you guys are still confused how I got the others, these are the two forces. So the red forces, the red arrows are the two horizontal forces. The net force is the sum of those two. However, since they're in opposite directions, we take the difference. So what is force of x? The applied force. Well, we use a method similar to how we find the applied force in the other direction. This is 36.2 degrees. This is a right angle. This is 12.2 newtons, and we want to find x. So we take cosine of 36.2 equals adjacent over hypotenuse. X equals 12.2 cosine of 36.2. So getting rid of all of this, we can move this part so we got this as f of x. So now what is force of friction? Force of friction is a coefficient times a normal force. That's the formula to find the force of friction. I'll write that over here. Coefficient times normal force. So, and we're given both. Well, we're given the coefficient. That's 0.387, and we found the normal force is 16.707. To find the net force, you just do that. So now plugging all this into a calculator, 12.2 cosine of 36.2 minus 0.387 times 16.707. Making sure everything's right. 12.2 cosine 36.2 minus 0.37 times 16.707. Now we get net force equals 3.379. I'll write that neater a little. 3.379 newtons. Now, let's go back to our initial equation. Net force is equal, acceleration is net force over mass. So 3.379 divided by 2.44 would give us 1.3849. So the answer is 1.3849 meters per second squared. And we want to find the answer, the option choice, very close to this. And while directly rounding will not give us 1.39, A is the answer very close to this. The difference is due to rounding, so some rounding differences and all. So it still doesn't matter. We would get A as the answer to number 7. Number 8. A 24 kilogram. Okay, one second. I'll zoom in. A 24 kilogram pickup traveling south at 24 meters per second collides with and attaches to itself a 4,000 kilogram pickup truck traveling east at 16 meters per second. Find the speed of the two vehicles just after the collision. So this is a momentum problem. Let's pull up Notability. Let's get rid of all this. Cut. So let's draw this diagram a little bit. So we have a 24 kilogram pickup truck traveling south. It collides to a 4,000 kilogram pickup truck traveling east. So the way we use this is using the law of conservation of momentum, which essentially states that the momentum before, so momentum before equals the momentum after. So what is momentum? The formula for momentum is defined as mass times velocity. So let's try to find the momentums before and the momentum after. The momentum of the pickup truck is mass, which is 2,400 kilograms, times velocity, which is 24 meters per second. Doing the math, 2,400 times 24 meters per second is going to be, will give you a momentum of 57,600. For the other truck, for the red truck, you're going to have a mass of 4,000 times velocity of 16 meters per second. You'll get a momentum of 64,000. So those are the two momentums you'll have. That's the initial momentum. Now, here's the thing. If they were in the same orientation, we can just add them like normal or subtract them. However, since these two are both vectors, momentum is a vector. You can align the vectors. Actually, I'll use a red arrow instead. You can align the vectors somewhere like this. These two right here are the initial momentums. And the green vector I'm going to draw right now is the final momentum. This is the green vector is the vector of the combined. When the vehicles crash and they're together, the green vector is the combined vector. So this is a simple Pythagorean theorem problem. So we know that this becomes 57,600. This becomes 64,000. So we want to find the hypotenuse. So this is just going to be the square root of 57,600 plus 64,000 squared. And finding that, 57,600 squared plus 64,000 squared, square root of the answer, you're going to get 86,103.9. 86,103.194. That's the momentum of the final object. But remember, momentum equals mass times velocity. We're trying to find the velocity of the object at the end. The momentum of the object at the end we found out is 86,103. And we know the mass of the two systems. When the two vehicles collide, what's their combined mass? We just add up their two masses times the final velocity. And now just solving for final velocity, you should be getting 64,000 divided by 64,000. You should be getting 13.454 meters per second. And that would be closest to 13.5. So the answer is going to be D. Number 9 is a torque problem. So we go to number 9. A 3.44 long uniform beam with a mass of 44.6 kilograms is free to pivot where it is attached. I'm going to actually delete this first before I move to this. Okay, so what do we have here? A A 3.44 meter long uniform beam with a mass of 44.6 kilograms is free to pivot where it is attached to a wall. A cable to the wall is also attached to the other side of the beam. Hold on, sorry. The sign hanging from the end of the beam has a mass of 65.7 kilograms. Find the tension in the cable. This problem has to do with torque. If you guys don't remember, torque is equal to force times radius times sine theta. That's the formula for torque. A property for, and this is a balanced system, nothing is moving. That means the net torque has to equal 0. Because it's not like the object is moving counterclockwise or it's not moving clockwise. Its position is staying the same, so there's no torque applying to this object at all. If you guys don't know what torque is actually, I should have explained this earlier. Torque is essentially acceleration in a rotational area, so in rotation. Think of acceleration, or torque is more of a force in a rotational area. So we know forces can be applied in a linear object. So if you apply force to a car, the car starts to move. Torque is force on a rotating object. So if you add force to a wheel, you add torque to it. So if net torque is equal to 0, that means the torque in the clockwise direction equals the torque in the counterclockwise direction. So the clockwise has to equal counterclockwise. So let's find the clockwise torque first. Let's find torque clockwise. This way. So what are all the forces on this diagram? Well, we know the beam has weight. We're given that the beam has weight to it. So there's a weight force from the beam. I should diagram in the red. There's a weight force to the beam. There's a weight force to this sign here too. The sign has mass. And what other forces are there? In the clockwise direction. That's about it. There's just a weight force to the beam, a weight force to the sign. Nothing else has weight in this problem. That also applies torque in the clockwise direction. So, clockwise torque, remember it's force times radius times sine theta. So, and since theta, okay, by the way, one more thing. Theta is the angle between these two lengths, the radius and the force. So in both cases, theta, okay, if I extend this line here, theta would equal 90 degrees. And sine of 90 degrees is 1, so we can actually completely ignore theta for this part. So we can do force times radius 1, force 1, radius 1, plus force 2, radius 2. So let's go for it. Force 1, that's just the weight of the beam. Let's do beam as force 1. The weight of the beam, we know it's a mass of 44.6 times 9.8 times 9.8. That's the weight of the beam. What's the radius? So this is the weight, the force. What's the radius of the beam? Well, we know the whole beam is 3.44 meters, and the center of mass of the beam, because the weight acts on the center of mass in the beam has to be half of that. So 3.44 over 2. The distance between the weight and the center of the axis of rotation is 1.72 meters. This is 1.72. That's the initial torque. The torque applied by the sign is going to be 65.7 times 9.8. That's the weight force. And now we want to find the radius, the distance between the weight and the axis of rotation. That distance is going to be all the way here. This is going to be 3.44. So now plugging everything into a calculator, let's see what we get. 44.6 times 9.8 times 1.72 plus 65.7 times 9.8 times 3.44. I get 2,966.656. Let's make that 2,966.656 Newton meters. That's the clockwise torque. What about the counterclockwise torque? What are all the forces going in the counterclockwise direction? I'll label this with the green arrow. The only force, there's only one force going in the counterclockwise direction. That's going to be this, the tension force by the cable. So, what is the force? Well, the force is essentially just the tension. What's the radius? What's the distance between the point where the force is acting on to the wall? That is just 1.72. Wait, actually, no, that is just 3.44. That is just because it's the same length here. It's all the way. I'll even draw it with a green arrow. A yellow arrow. It's this entire length here. This is because remember this blue point. That's the axis of rotation. The radius is the distance between the axis of rotation and the acting point of the force. And this black dot I'm drawing right here, that's the acting point of the force. That's where the force, the green arrow, starts. So that distance is 3.44 meters, which is given. But we're not done yet. Remember, the formula to find torque was force times radius times sine theta. So what is the sine theta? Well, actually, wait, hold on. What is theta? Theta being the distance of force and radius, that would be 30 degrees in this problem. So we know that torque clockwise equals torque counterclockwise. So we can actually copy this number here, paste it over here. These two have to equal. And finding the value of tension, because that's what we're trying to find, tension is going to be tension. If once you plug it into the calculator, you will get tension force equals 1724.8 newtons. This is the final answer. So I'll just get rid of that. That's the final answer. 1,724.8 newtons. And this is very close to answer choice A. So the answer to number 9 is going to be A. Number 10. Let's erase the work from the previous one. Oopsies. Cut. Number 10. The relative intensity of the sound produced by a trumpet is 96 decibels. If two trumpets play at the same time, what is the relative intensity of the sound produced? So, there's one key formula you all have to memorize. The intensity level is equal to 10 times the log of the intensity over 10 to the power of negative 12, which is known as the threshold intensity. So B will be intensity level in decibels. I will be intensity in watts per meter squared. So, based on this, how are we supposed to do this answer? Well, we're given the intensity level, 96 decibels. And we know that two trumpets have to be playing together, and we're trying to find relative intensity. Relative intensity is nothing different as intensity level. So, we're trying to find B. Well, we know the intensity level. Let's try to find the intensity of one trumpet. Intensity, not intensity level, not relative intensity. So, we know that the intensity level of the trumpet is 96 decibels. And solving for I, if you know your logarithm, actually, I'll run you guys down with the logarithmic part of this. Divided 10 both sides, you get 9.6 equals log I over 10 to the negative 12. And taking both 10 to the power of both of those answers, 10 and log would cancel out, so you get 10 to the power of 9.6 equals I over 10 to the power of negative 12. And then multiplying 10 to the power of negative 12 to both sides, you would get I equals, and just plug that into the calculator. Plugging that into a calculator, you would get an intensity level of 0.0398 watts per meter squared. But that's the intensity for one trumpet. What is that asking? What is the question asking for? Intensity of two trumpets. So you want to multiply this intensity by 2. So 2 times intensity is just going to be 2 times 0.0398. So the new intensity, so I'll call it final intensity, is going to be 0.0. And wait, hold up. This is actually a slight typo here. This should actually be 0.0398, not 0.0398. So the final intensity, if you multiply by 2, you would get 0.00796 watts per meter squared. Now, plugging this back into the initial equation all the way in the top, we would get relative intensity equals 10 log of final intensity, which you just calculated, over 10 to the negative 12. And plugging everything in, we've got final intensity divided by 10 to the power of negative 12. Log of that number times 10. Intensity level would be 99.0103 decibels. And the closest value in this problem would be 99. So the answer to this problem is going to be B. Number 11. This one's going to be a bit shorter than the others. What is the maximum possible efficiency of a heat engine that operates between 160 degrees Celsius and 380 degrees Celsius? So the maximum possible efficient energy, which is also efficiency, which is also known as the Carnot efficiency, is equal to 1 minus the temperature of the cold reservoir divided by the temperature of the hot reservoir. And both of these have to be in Kelvin. That's actually, in chemistry and physics, literally everything has to be in Kelvin. That's one thing you have to keep in mind. So, let's do the math. The cold reservoir is 160 degrees Celsius, but you want to convert that to Kelvin by adding 273. And the hot reservoir is 380 degrees Celsius. You want to convert that to Kelvin by adding 273. And just plugging everything in, 160 plus 273 divided by 380 plus 273, 1 minus that answer, you're going to get 0.337 as your Carnot efficiency. So the answer to this question is going to be letter B, P11. Number 12. Find the current in the 240 ohm resistor. Let's remove the work here. Cut. Now, to do this, you need basic knowledge on series and parallel resistors, circuits. So I'll quickly run them down for you. If you have multiple resistors in a series circuit, so if they're in a straight line, the total resistance is equal to the sum of the resistors. If you have resistors parallel to each other, something like this, where this is R1 and this is R2, the total resistance is going to be the sum of the reciprocals. Technically the reciprocal of the sum of the reciprocals. These are the two formulas that you must keep in mind if you want to solve this problem. So I'll jot that down and I'll delete it for now. Now what we're trying to do is we're trying to convert. Well, first of all, actually before that, we also need to know Ohm's law. Ohm's law, which states that voltage is equal to current times resistance. So we're trying to find the current. That's actually what we're trying to find. And we're given in the 240 ohm resistor. So let's go back and let's like try to solve this problem. And we're given the voltage. We're given the voltage is 120. 120 equals the current times the total resistance. That's where RT can play. The total resistance. We want to find a resistor that combines the values of all these terms. And since they're not all in series, you can't just add them all up. There's one parallel circuit right here. Remember where there's when the resistors are parallel to each other. That's a parallel circuit. So let's solve the parallel circuit first. So you have a 180 ohm here, and you have a 60 ohm here. So the total resistance is equal to the sum of the reciprocals, the reciprocal of the sum of the reciprocals. So 1 over RT equals 1 over 180 plus 1 over 60. 1 over R. So then, plugging everything into a calculator, you would get 1 over 180 plus 1 over 60, 1 over the answer. The total resistance would be equal to 45 ohms. What this essentially means is that if you had a circuit, instead of having this, you could have instead just had a normal resistor with the resistance of 45 ohms. Instead of having that parallel circuit, an equivalent would just be having a 45 ohm resistor. So let's actually replace this. Wait, let's increase the width of this pen. Let's actually replace that resistor with a 45 ohm resistor. So this is a 45, dial down the thickness to this. This is a 45 ohm resistor. Now, notice all three of these are in series. So we can just add them up. So the total, so we have, we can just add them up. Total resistance equals 240 plus 90 plus 45. 240 plus 90 plus 45 gives you 375 ohms as the total resistance. So now using the Ohm's law, voltage is 120, current is what we're trying to find, and resistance is 375. Solving for current, we're going to get 120 divided by the answer. We'll get 0.32 amps. So, positive terminal, negative terminal. That means the current is going through this. Okay, another property is that current stays the same throughout a series circuit. In a parallel circuit, that's different. Current does not stay the same throughout a parallel circuit. That depends on the resistance. But in a series circuit, current does not depend on resistance. It stays the same throughout. So the current in this entire place is 0.32 amps. So through the 240 ohm resistor, it would be 0.32 amps. And like I said, I'll repeat it one more time. In a parallel circuit, this would not be the answer. It would not be 0.32 amps. Just for your own knowledge, I'll show you the resistances. You can skip ahead if you guys want, but if you guys want to know how to do it, like in a future problem, if it's asking you to find it for a parallel circuit, we know the current entering is 0.32 amps. Right, the current through. However, voltage is equal to current times resistance. Since the voltage stays the same in a parallel circuit, voltage stays the same in a parallel circuit, current does not. So we can find current equals voltage over resistance. That's what we can derive. Current equals voltage over resistance. I'll move that down a little bit. So clearly current and resistance are inversely proportional to each other. as resistance goes up, current goes down. So that means the one with the higher resistance must have the lower current. This must have the lower current than the other one. The 60 ohm resistor has a higher current through it. The 80 ohm resistor has a lower current through it. And the ratio of the current is the same as the ratio of the resistors. So 1 over 80, 180 over 60 is equal to 3. That means if this was x, this would be 3x. And to check your math, just multiply the resistance and the current, you will get 180x. Multiply the resistance and current, you will get 180x. That's the voltage. But what exactly is x? X is the current, right? So x and 3x combine to make 0. Because the output is also 0.32 amps. So x plus 3x is 4x equals 0.32 amps. So 4x equals 0.32. X equals 0.08. And 3x would equal 0.24. So the current through the 180 ohm resistor, would be 0.08 amps. And the current through the 60 ohm resistor would be 0.24 amps. So I'll just draw. And that's how you find the current through a parallel circuit. Obviously, that's not what we need for this problem, but that's just in case. A point charge of positive 300 microcoulombs is placed at A, and a point charge of negative 500 microcoulombs is placed at B, and a point charge of 100 microcoulombs is placed at point C. Find the magnitude of the net electrostatic force on charge B. So, oh my god. So, what are exactly some things we must know for this problem? Well, you should know that the formula for the Coulomb's law, it's known as Coulomb's law. Coulomb's law. It's net is the force, the attractive force between two charges, or attractive or repulsive force depending on the charge. Like charges repel, opposite charges attract, is equal to Coulomb's constant times the first charge times the second charge over the distance between the two charges squared. I've actually seen it as written as radius squared, r squared, where capital Q is charge 1, lowercase q is charge 2, r is distance, and K is equal to 8.99 times 10. If you're given this on the answer sheet, don't worry guys, you don't need to memorize the K value, Coulomb's constant it's known as. You're given that on the answer key, on the exam itself. It's 8.99 times 10 to the power of 9. This is known as Coulomb's constant. So, what are we trying to find? Well, we know the point charge on A is positive. If we look here, the point charge on A is positive. The point charge on B is negative. And the point charge on C is positive. We know opposite charges attract and like charges repel. On point B, point A and point B are having attractive forces. I'll actually draw that in blue. Point A and point B are both having attractive forces. Point B and point C are also having attractive forces. I'll draw that in green. Point B and point C. We want to find the net electrostatic force. I'll draw that in yellow. The net... Okay, actually, that's hard to see. Let's draw in black, it's fine. The net electrostatic force, which if you remember the magnitude question, we can align the dots like that. We can draw a vector between the red and the blue and the green arrow. That is the net force. We're trying to find the black arrow. This black arrow right here. We're trying to find that. That's the net force. So, how do we find that? We will first have to find the blue and the green arrow, the vectors, and add them up. Using Coulomb's constant, let's try to find the blue vector. So the blue vector is going to be force equals Coulomb's constant is 8.99 times 10 to the power of 9. The first charge, wait one sec. 9 times 10 to the power of 9. Yeah, make sure that my constant's right. The first charge is going to be 300. It doesn't matter the order, but 300 times 10 to the negative 6. This little u, that's called a micro. Micro is essentially 10 to the negative 6, just like on millis 10 to the negative 3, centis 10 to the negative 2, micros 10 to the negative 6. And the second charge, you don't need to focus on the sign, actually, at all, so just write 500. You don't need to write negative 500. And the distance between the two charges, this distance has to be in meters, by the way. So we know ABC is a right angle. BC is 5. AC is 10. So that means using Pythagorean theorem, AB has to be 5 root 3. And since everything's in centimeters, 5 root 3 has to be converted to meters. So I'd multiply 10 to the power of negative 2. That's a distance, and you want to find distance squared. Plugging everything into a calculator, let's do it. 8.99 times 10 to the power of 9 times 300 times 10 to the power of negative 6 times 500 times 10 to the power of negative 6 divided by 5 square root of 3 times 10 to the power of negative 2 squared. You will be getting equal to 179,800 newtons. That's the blue arrow force. That's the, I'll draw it right here. This is 179,800. Now, what about the other force? This be force 1, let's be force 2. What about the other force? What about force 2? Same exact method. 8.99 times 10 to the power of 9 times, the charge on point C is 100 microcoulombs. The charge on point B is 500 microcoulombs. The distance between B and C is 5. 5 centimeters, convert that to meters, 10 to the negative 2 squared. And 8.99 times 10 to the power of 9 times 100 times 10 to the power of negative 6 times 500 times 10 to the power of negative 6 divided by 5 times 10 to the power of negative 2 squared. Well, we'll say squared. And coincidentally, we get the same answer of 179,800 newtons. So this is also 179,800. So drawing the triangle, the vector triangle, if this was the blue, okay, if this was the blue arrow and this was the green arrow, this would be the black arrow. This would be 179,800. This would be 179,800. So using Pythagorean theorem, you would get, the black arrow would be 254, 275, and because this would be a right angle, 254,275.599 newtons. There's your answer, and that would be closest to letter E. So the answer to this question is going to be letter E. Alright, so number 14. I will erase all my work here. A long straight vertical wire carries a current of 56.8 amps. The magnitude of the magnetic field at point some millimeters away from the wires, from far from the ends, is 5.12 microteslas. So a current of 56.8 amps. We want to find the magnitude at a point certain meters away, and we're given the magnitude of the magnetic field. So Now we want to use a version of Ampere's law. This version, the way to find not current, magnetic field. Magnetic field is equal to the permeability of free space times the current flowing through the wire over 2 pi times the distance between the wire and the point. So what this is trying to find is the magnetic field. If there's a certain current flowing through this wire, the magnetic field at this point. Because we know current generates magnetic fields, right? Currents generate magnetic fields. What is the magnetic field at this point? What is the magnetic field? So I will define each value. B is the magnetic field. It's measured in Teslas. I is current. It's measured in amperes or amps. R is distance. It's measured in meters. And the UO, it's known as the permeability of free space. It's another constant that's given to you on the test, so you don't need to memorize it. It's equal to 4 pi times 10 to the power of negative 7. So now, this is just straight up plugging in all the numbers. So magnetic field in Teslas, 5.12 milliteslas. Millitesla, so times 10 to the power of negative 3. Since it's milliteslas and not Teslas. Equals the permeability of free space times the current over 2 pi times the radius. We're trying to find the radius. Or R, actually. No, it's not the radius, it's actually the distance. So, taking your calculator and just trying to isolate R, you're going to get... So actually, I won't just copy it down too long. And just move this, replace that with this number here. This is just simple algebraic manipulation, replacing the R and the 5.12 times 10 to the negative 3, plugging all those numbers in. 4 pi times 10 to the power of negative 7 times 56.8 divided by 2 pi times 5.12 times 10 to the power of negative 3. So the distance between the point and the wire is going to be 0.00229 meters. And we're trying to find this in millimeters. So we multiply this by 1,000. So this would be 2.20 okay, wait, another small mistake here I made. This is 2219. So if you multiply it by 1,000, you get 2.2219. 2.219 millimeters. This is very close. This is the answer. 2.219 millimeters. That's very close to letter C. 2.2 millimeters. Number 15. A circular coil of wire with 60 turns and a 3.62 centimeter radius is positioned between the poles of an electromagnet that produces a steady magnetic field of 1.12 teslas. The surface of the coil is originally parallel to the field, and it is rotated so that the plane of the coil is perpendicular in 0.025 seconds. Find the averaged induced EMF. So to solve this problem, you'll need to know Faraday's law to solve this problem. So Faraday's law. Faraday's law is induced EMF equals -1 times the number of coils times the change in magnetic flux over the change in time. So induced EMF, so I'll just label, induced EMF has to be in volts. The number of coils, this new symbol, you've probably not seen this before. This is called the change in magnetic flux. Change in magnetic flux. It's measured in a unit called Webers. And last one is change in time. Change in time. So these are the four you'll need to know for this equation. There's one more equation you guys have to know if you want to solve this problem. It's change in magnetic flux equation. Change in magnetic flux is equal to change in the magnetic field times the area of the coil times cosine of theta. And I'll show you guys what each means. So B is magnetic field. A is area. So magnetic field in Teslas, area in meters squared. Theta is the angle between the magnetic field and the normal line. And I'll explain what the magnetic field and the normal line are. So let's diagram this problem. I'll erase this. Let's diagram this problem. So you have a circular coil of wire with, you have a circular coil of wire with 60 turns. Each turn has a 3.62 centimeter radius. So the magnetic field I'll diagram in the color blue. The magnetic field is initially parallel to the field. I'll diagram the normal line in green. The normal line is perpendicular to the coils. That is the angle between the magnetic field and the normal line. However, the surface of the coil is then rotated. So the surface of the coil is later rotated. So that means the normal line also becomes rotated. So I'll just do it before and after. So can we no. I'll just move this up here. That's the before. After the change, the coil is now like this. It's vertical. The normal line is passing like this. And the magnetic field is passing like this. So, based on this, so what do we know? What do we know from this? Let's first find the change in magnetic flux. Change in magnetic flux is equal to change in BA cosine theta. There has to be a change in one of these. Let's identify what is being changed. Is the magnetic field being changed? The magnetic field stays the same. It's still 1.12 Tesla. Is the area of the coil being changed? The area is still, the area of a circle, because it's a circular coil of wire. Area of a circle is pi r squared. So pi times the radius of the coil is 3.62 centimeters. That'd be 0.0362 meters squared times, now we have to multiply this by the change in cosine theta. Cosine theta does change. The angle between the normal line and the normal line and the magnetic field. So the blue line is the magnetic field and the green line is the normal line. The angle between the normal line and the magnetic field change from 90 degrees to 0 degrees. So we do final minus initial. Whenever you do change, it's always final minus initial. Let's bring this down. So it goes final is 0, initial is 90. So let's bring this here. Equals cosine, the final angle is 0 degrees. The initial angle is 90 degrees. Something like this. And plugging all of this in, let's see what we get. Plugging everything in, you would get 0.00461 Webers as the change in magnetic flux. So let's delete all this. So we know the magnetic flux is equal to this value. So now we know the magnetic flux. What do we do with that? Well, the equation, we want the number of coils, the change in magnetic flux, and the change in time. Well, we have everything else. The number of coils is given to us as 60. We calculated the change in magnetic flux. And we know that this all happened in 0.0225 seconds. So plugging in all the answers, you would get negative 12.296 volts as the answer. That's the induced EMF. However, it's asking you to find the magnitude. So you take the absolute value of that. So negative 12.296, the absolute value of that is just 12.296 volts. That's the answer, 12.296, which we would round to 12.3. So the answer to number 15 is going to be E. Number 16. A 2-inch candle is placed 16 centimeters from a concave mirror with a radius of curvature of 36 centimeters. Describe the image. So you're going to need, so this is an optics question. There's always going to be one of these on each test. And to solve this problem, well, let's quickly diagram what's going on. We have our concave mirror here. Shade that in blue. This is our mirror. And you have a candle here. Let's draw the best drawing of a candle. And it is placed 16 centimeters away from the mirror. And the mirror has a radius of curvature of 36 centimeters. I'll explain shortly what that is. So this is the center. The radius of curvature is 36 centimeters. Okay, for these problems, we're first going to need there's two equations that you must know if you want to solve these problems. 1 over the focal length equals 1 over the distance between the object and the lens plus 1 over the distance between the image and the lens. If you put an object in front of a lens, there's going to be an image. Well, there could be an image. There can be an image that's shown. So you'll have, if the image is like this is an inverted image. This is when the image is flipped over. If the image looks like this is known as an erect image. That's erect. And the previous one was inverted. If the image ended up growing in size, that is called enlarged. That's an enlarged image. If the image was reduced in size, it would have been a reduced image. And another property you must know is that if the image may not always be there. If the image is actually there, an actual true image, it is called real image. But if there is no image at all, if there's no image whatsoever, this would be called a virtual image. If there's if you draw the rays, there would be a hypothetical image. This would be called a virtual image. Hypothetical. Real images, you can actually see it. Virtual images, no, you can't, but it's just like a theory image. So, what is this formula here? F stands for focal length. DO is this object. It's the distance between the object and the lens. DI is the distance between the image from the lens. So how do we find? So we're given we're trying to find DI. That's our goal for this equation. The distance between the image and the lens. We're given DO. DO is 16 centimeters. The candle is placed 16 centimeters. What about F? Well, F equals F equals the radius of curvature divided by 2. So R is radius of curvature. So, see this green line here? I'll draw a blue line between the lens, or I'll just draw between the lens and this point here. That right here is the focal length. This blue line I just drew is F. The focal length is the point where all the light rays, when they bounce off, they will intersect this length. All these rays, they're bouncing off, they're going to hit the blue dot. That's the focal length. So, and the focal length, I know the drawing is not properly showing it. The focal length is half the radius of curvature. The center is essentially like the point, the center of this entire, like, if you can draw a circle. It's like it says, you can draw a circle, a full-on circle between the center and the lens. So, radius of curvature divided by 2 is focal length. So that means radius of curvature is given as 36 centimeters divided by 2. The focal length is 18 centimeters. So we know the focal length is 18 centimeters. Now let's, using this formula, 1 over 18 equals 1 over DO, which we know is 16 centimeters. The object's 16 centimeters from the lens, plus 1 over DI. Solving for DI gives you, 1 over 18 minus 1 over 16, 1 divided by the answer. It gives you negative 144 centimeters. Now, what do we do with this value? We look at the sign. If this sign is negative, as shown here, it is a virtual image. You can easily tell because obviously distance can't be negative. Like, you can't have negative 144 centimeters. This is a virtual image. If it had been positive, if it had been 144 centimeters, this would have been a real image. Since it's negative, it would be virtual. So let's look at the answer choices. It has to be virtual, so we can eliminate A, C, and E, because all three of those show real. So we're left with B and D. So I'll just let's draw that in red. Eliminate A, C, and D. So now we have a virtual image. How do we know if it's erect or if it's inverted? How do we know if it's reduced or if it's enlarged? We look at the magnification. There's one other formula you guys want to know. Magnification equals negative DI over DO. The distance between the image and the lens, and the distance between the object and the lens. So M is magnification. So that's M. Now let's calculate the magnification. Negative DI, which we calculate as 144. DO is 16. If we do the math, negative 144 divided by negative 16, you're going to get 9. Now we look at the sign for this. If it's negative, it would be inverted. It would be inverted. If it's a positive sign, it would be erect. So inverted and erect. So we know that since this is a positive sign, the image will be erect. Looking at the answer choices, both B and D show erect, so that's not really helping us. But we have to move on to the last step. Now, magnification is also equal to the height of the image divided by the height of the object. So the height of the image is what we're trying to see. The height of the object we know is 2. It's 2 inches tall. So magnification is 9 equals the height of the image divided by 2. Height of the image has to be 18 centimeters. So the initial height was 2 centimeters, and the final height was the image height was 18. So the image was increased. The image has been enlarged. So if the height increases, it's enlarged. If the height decreases, it's reduced. You can also tell by looking at the magnification. If the magnification is if the absolute value of the magnification is between 0 and 1, then it's reduced. Reduced. If the absolute value of the magnification is greater than 1, it's enlarged. So using that, we can tell that 9 is absolute value of 9 is greater than 1, so it has to be an enlarged image, making our answer D, enlarged image. Number 17 is talking about a photoelectric effect question. So, a 190 nanometer ultraviolet wavelength photon is absorbed by an electron on the surface of an aluminum target, which has a work function of 4.21 electron volts. Find the maximum possible speed of an emitted electron. So, the photoelectric effect. The photoelectric effect. What does it state? It states that when light shines on a metal plate, the electrons will start to gain energy. And once the energy of the photons exceeds the work function of the electron will start to leave the metal plate at a certain velocity. So, what equation can we use for this problem? The energy of the photon equals the work function plus the energy of the emitted electron. So, we want to find the maximum possible speed of an emitted electron. Let's first try to find the energy of the emitted electron. That would be equal to the work function. The energy of the photon minus the work function. Energy of the photon. Well, energy in general, any particle can be written as Planck's constant times the frequency of the particle. So H is Planck's constant, or 6.626 times 10 to the negative 34. F is frequency in hertz. So frequency in hertz. That's the standard unit for frequency. F is also equal to, F is equal to the speed of the particle divided by the wavelength of the particle. Now, what is this particle? This particle is a photon. Photons are light particles, so they go at the speed of light. So the velocity in this case would be speed of light divided by the wavelength. And yeah, this would be wavelength in meters. Make sure to keep that in meters, not in nanometers. So, plugging this value into F, what would you get? You're going to get Planck's constant times speed of light divided by the wavelength. That's the energy of the photon. And we know all that. We know Planck's constant. We know the speed of light. Speed of light is given to you in the formula sheet. 3 times 10 to the power of 8 meters per second. And we're given the wavelength in the problem, 190 nanometers. Plugging in all the values, 6.626 times 10 to the negative 34. Speed of light is 3 times 10 to the 8th. And wavelength is 190 times 10 to the negative 9. Because we got to convert that to meters. You can't just leave it in nanometers. Plugging all that into a calculator, 3 times 10 to the 8th divided by 190 times 10 to the power of negative 9. You're going to get an answer of 1.046 times 10 to the negative 18. I'll bring that down here a little bit. I'll erase all this. I'll erase all that. So cut this thing. So the energy of the photon will be equal to 1.046 times 10 to the negative 18 joules. So that's the energy of the photon. What's the work function? We want to find the work function too. The work function is given to us, 4.21 electron volts. But we want to convert that into joules. We know 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. This is also given on your formula sheet, so you guys don't have to memorize this. And plugging that in, into a calculator. 602 times 10 to the power of negative 19. You're going to get 6.744 times 10 to the negative 19 joules. That's the work function. So we got the photon energy and the work function. Plugging that into this formula, we know the energy of the electron equals, and then subtracting the two values we got, 3.717 times 10 to the negative 19 joules. That's how much energy the emitted electron has. Now, we want to find the speed. We're trying to find the speed of the electron. If you've taken physics 1, you know that the kinetic energy of an object is equal to 1/2 mv squared, where m is the mass, v is the velocity. So, we use this formula, equate that to what the number we got, so 3.718 times 10 to the negative 19, and we want to find velocity. We know the mass of an electron. Mass of an electron is given to us. It's going to be, mass of an electron is going to be 9.11 times 10 to the negative 31. 9.11 times 10 to the negative 31. That's the mass of the electron. So you're going to get 1/2 times 9.11 times 10 to the negative 31 times v squared equals 3.718 times 10 to the negative 19. Plugging in, and now you want to solve for v. So times 2 divided by 9.11 times 10 to the power of negative 31. Take the square root of that. You would get velocity of the electron equals 903,425.04 meters per second. This is our answer. And that would correlate closest to letter A. So letter A is our answer for number 17. Number 18. Which quark belongs to the second generation of quarks? This is a knowledge question, so you just have to know this off the top of your head. The first generation includes up and down quarks. The second generation is strange and charm. The third generation is top and bottom. So the second generation would be number 3 and number 4. So the answer to this question would be E. Number 19. Jeffrey was part of the crew that visited Planet Y in 2016. He conducted an experiment to find the acceleration of gravity on this exoplanet. He used a pendulum and carefully measured the period of vibration as he varied the length. He used a graph above to calculate to find what he calculated. So number 19 will always be a graph question. Sometimes number 20 is also a graph question. So we need to know the formula for a pendulum, to finding the period of a pendulum. The period of a pendulum can be found using this formula. T equals 2 pi square root of the length of the pendulum divided by the acceleration due to gravity. So T equals, to find what all these mean. T is the period in seconds. L is length in meters. G is acceleration from gravity. And this will be in meters per second. Now, acceleration from gravity, as we saw in the other videos, in Earth it's 9.8. But this is on an exoplanet, so we're trying to find the acceleration due to gravity. So let's rewrite this equation in terms of with G, like solve for G. So we can do step by step. Square root of L over G equals T over 2 pi. L over G equals T squared over 4 pi squared. G equals 4 pi squared L over T squared. This is the formula you'll be using to solve for, wait, hold up. Yeah, sure. This is the formula you'll be using to solve for this problem. So now, plugging in all the values, we know length and the period can be found in this table and in the graph. So length, let's take this blue point right here. If the length is equal to 3.2 meters, period is equal to 4 seconds. Period's 4 seconds, or actually wait, not p. T equals 4 seconds. G equals 4 pi squared times 3.2 over 4 squared. Solving for this, you're going to get G equals 7.896 meters per second. So the answer is 7.896, or 7.9. Number 20. Calculate the de Broglie wavelength of an electron that has been accelerated across a potential difference of 2,000 volts. So you're trying to find the de Broglie wavelength. So what is de Broglie wavelength? It is equal to the Planck's constant divided by the momentum of a particle. Planck's constant, we got 6.626 times 10 to the power of, where's Planck's constant? Planck's constant, 10 to the power of negative 34. And momentum is the same thing as mass times velocity. We can rewrite P, then, to be equal to mass times velocity, times velocity, h over mv. So we're trying to find this right here. To find that, we need 3 of these. How many of these do we already have? We already have the Planck's constant. It's a constant, so we're given that already. And we have the mass of an electron. It's given on the formula sheet. But we need to find velocity. To do that, we have to realize what else we're given. We're given the potential difference in voltage. We're essentially given the voltage that the electron has been accelerated across. So we know the formula for voltage is equal to energy, or actually in this case, like most of the time, you would write it as work. Work divided by charge. That's a formula for voltage. So work equals voltage times charge. So now, what is voltage and what is charge? Voltage is 2,000. It's given to you in the problem. And charge, also known as the fundamental charge, since we're talking about an electron, the charge would be, where is it? Fundamental charge. 1.602 times 10 to the power of negative 19. That's the fundamental charge. Now to find the work, you're going to be multiplying those two. So 2,000 times 1.602 times 10 to the power of negative 19. So, yeah. You would get 3.204 times 10 to the power of negative 16. If I did my math correctly, which I think I did. So, 3.204 times 10 to the negative 16. We know work is, and this is joules. Make sure, keep the unit in mind. So we know energy, work is essentially the change in energy. There was no energy before. So in this case, energy would equal work. And energy is also written as 1/2 mv squared. That's kinetic energy. The formula for kinetic energy is 1/2 mv squared. So 1/2 times the mass of the electron, which is electron mass 9.11 times 10 to the power of negative 31 times velocity squared equals 3.204 times 10 to the negative 16. We can try to solve for velocity. And once we isolate velocity and plug into a calculator, velocity of the electron equals 265,21743.04 meters per second. So 2 million meters per second, 2.6 million. Now, plugging this back into the initial equation, what can we get? We know Planck's constant is 6.626 times 10 to the power of negative 34. Mass of the electron is 9.11 times 10 to the power of negative 31. And velocity is going to be the value we got, 2.6 million. Just going to write that here for now. Now let's try to find the de Broglie wavelength by plugging all these values in. Just make my 9 a little neater. So speed times 9.11 times 10 to the power of negative 31. 6.626 times 10 to the power of negative 34 divided by the answer. You would get 2.742 times 10 to the negative 11 meters. So this is how many meters you're going to get. But obviously, all our answers are going to be either picometers or nanometers. Picometer is 10 to the negative 12. So 1 meter equals 10 to the 12 picometers. 1 meter equals 10 to the 9th nanometers. So convert this into nanometers and picometers. In nanometers, this would be 2.742 times 10 to the power of negative 2 nanometers, which is not given anywhere in the nanometers, so we can eliminate those two. In picometers, multiply 10 to the negative 12, you would get 27.42 picometers. So the answer to this one would be B, 27.4. And we're done with all 20 problems. And if you start from beginning to end of the entire test, you'd be done with the test by now. So I know this section, physics section, is definitely like probably the hardest out of the three. There's a lot of formulas you need to know, a lot of concepts you need to know. So feel free to answer and to ask any questions in the comments. And I know I might have rushed it a little bit since it's like my first video, so I might have rushed it a little bit. So feel free to let me know where you need help in anything. I hope you guys enjoyed this video. Please be free to subscribe to the channel and like the video if you enjoyed it. I'll see you guys when I make the next virtual challenge meet video.